This is Jeremy Yang, and this is Applied Data Science and the tutorial to help you do Assignment 9. This tutorial is about Python and several packages which are useful in doing data analysis and machine learning. There's a few other things involved in this tutorial which I'll mention in passing and you may want to investigate, but are really not essential, so I won't speak much on them. First is what you're looking at, which is a Jupyter notebook with the Python kernel, which used to be called IPython. It's a handy way of doing a demo like this, and it may or may not be useful to you for development and other purposes, but it's a nice thing to have for a lot of reasons. This also is something called Collaboratory, which is a free cloud service from Google. It's free, but you have to register, and it's not clear to me right now whether everyone gets automatically registered for it by asking. So it may or may not be available to you. I hope it is. Okay, with that, the Python packages involved are something called pandas, which is useful for data analysis, matplotlib for plotting, and most importantly, Scikit-learn, focused on predictive modeling and machine learning. And the two algorithms which we're focused on here are Naïve and neural networks. We see in this first code segment all the import statements in Python which import these packages. If you are running Python in a different environment, you may need to install these packages. I run that code section and there's no output, but the Jupyter notebook tells me that I've executed that. This next bit of code is a convenience function which helps indicate what the performance of a predictive model is. Next, we need to get our data. And the data for this demo or this tutorial comes from something called the UC Irvine Machine Learning Archive. Another thing I won't talk much about, but you may be quite interested in. We can pull a data set via public URL from their website and read it into a pandas data frame, and then have a little look at it. This CSV file does not have headings, so we have to assign heading names, which actually come from a separate metadata file we'll have a look at in a moment. We can see that the data frame has 9 columns and 768 rows. And we can look at the top of the data file and see that it looks reasonable. There are some descriptors related to health and medicine, and in the final column, the so-called class, indicating the outcome we're interested in, otherwise known as the endpoint or class label. There's various terms we use. And in this case, a 1 or a 0 indicates the presence or absence of a diabetes diagnosis. So that's the variable that we're trying to predict in our predictive modeling. Here's the one place we use the plotting package, matplotlib. And in this case, just to show you how that would be done, we look at a histogram of the BMI, the body mass index. As I mentioned, the metadata is in a separate file, also online. We can pull that down via URL, have a look at it here. If we were doing a project with this data set, we'd need to study this carefully. Next step, separate the input variables from the class labels into X and Y arrays. This is conventional notation in Scikit-learn. Then we separate the cases into a training set and a test set, 75%, 25%. And so we end up with two separate training and test sets, which is best practice in machine learning. With the data thus organized, we can run naive Bayes, we can run neural networks, we can run many algorithms from Scikit-learn, which is a very nice thing about that package. It allows you to switch from one to another. Here we're doing two, but you are welcome to try other algorithms based on your interest. So with naive Bayes, we train the model on the training set, then we test it on the test set using those known, that class column as the known labels, and then we can compute performance metrics such as the simple metrics, true positives, true negatives, false positive, false negatives, and then some metrics, precision recall and F1 score, which I invite you to learn about. Same procedure generally with the neural network approach, and we get our performance metrics, and we can then decide whether this is good enough or whether we might like to modify our approach to achieve better performance. We'll stop there. Enjoy your machine learning, and see you next time.